Welcome to the logarithmic graph and its translations. Just a reminder that log base e of x is the same as ln x. So on your calculator, you'll see it as an ln button, which means log base e of x. Little things to keep in mind is that logs and exponentials are opposite, so the inverse of each other, or they undo each other. So log base e to the power of x, so because it's log base e to the e, that in a sense cancels and we're left with the x. Or you could bring the x out the front, and we know the log base ev is 1. One of the ones that sometimes gets a bit confusing is that e to the power of ln x, an e and an ln cancel, and we're just left with what's after the ln. So this might be maybe applicable as we go through and do some questions. We're about to have a look at the curve, y equals log ex. It's always concave down, so remember it's the opposite of an exponential. So log curve is always concave down, so it's always pointing downwards. And it is increasing, so it does go up, but the rate it increases is actually slowing down. So it's increasing at a decreasing rate. And let's have a look at our graph. So you can see that it's concave down. It's always pointing downwards. But the curve, as the x values get larger, so as our x values increase, the rate or the steepness decreases. So it's increasing at a decreasing rate. The log approaches the y-axis, that's our asymptote, but doesn't actually touch it, passes through 1 on the x-axis. So now we're going to have a look at shifting some of our curves. So one of the little things that we did before. So we're applying some of those rules. So log e of minus x. So remember, if it hits the minus on the x, that rotates it across the y-axis. If we affect the function, so in the second example, so if we minus the 3, we move it up or down. So in this case, minus 3 is going to move the whole graph down 3. And the last one, if we affect the x, that shifts left or right. So x plus 2 is going to shift it 2 to the left. So minus 2. So here's our first one. So minus x. So the effect is on the minus x, flips the graph across the y-axis. So the asymptote is still the y-axis. The next one moves the graph down 3. So it originally passed through at 1, 0, 1, 0. It now passes through. If we move that down 3, the new point is 1 minus 3. So the blue one is the new graph. We've just moved everything down 3. So it still approaches the y-axis as our asymptote. And we can find where it cuts the x-axis if we let y equal to 0 and solve. And the answer ends up being e to the 3. And the final one, if we move it 2 to the left. So the x plus 2, the effects on the x, moves it left or right on the axis. In this case, it's moving it 2 to the left. Okay, so it goes from currently cutting at 1, 0 to moving it 2 to the left, meaning it now cuts at minus 1, 0. Our asymptote used to be the y-axis, but if I move that 2 to the left, my asymptote now becomes x equals negative 2. Is that my new asymptote?